Welcome to the CS4 Interview. Joining us this week is Dr Alex Penn from the University of Surrey. She's going to be talking about industrial ecosystems. A bit more about that later. But I wanted to ask you, how did you get into all this? Because your first degree was astrophysics, right?
Well, physics originally was what I did. And I basically sort of ironically thought I didn't want to spend all my time in front of a computer, which is what astrophysics really entails these days. And I actually moved into biology, complex adaptive systems. So I went to Sussex and did
where we met,
yep. And did the evolutionary and adaptive systems MSc there. And then moved into looking at the evolution of cooperation, major transitions in evolution, all sorts of very theoretical questions in biology. But even at that point, obviously there was a complexity science angle because I was in an interdisciplinary group and because of the MSc that I'd done, which gave me a broader perspective on looking at these of biological systems as systems in a broad sense, and maybe considering a bit outside the box of the neo-Darwinian paradigm. But I was also always very interested in application, and so I actually went out to Spain and worked with an NGO using imposing
your plant pops in Spain.
Yeah, so we tried to use this sort of ecosystem selection, the idea of evolving whole soil ecosystems to regenerate soil ecosystems in arid conditions in degraded land in Spain. So, it's always liked to kind of go out and apply things. I'd always also worked in sustainability. I was very interested in systems approaches to sustainability and what complexity science could offer sustainability. And so after doing a postdoc here at Southampton, in which I was having a lot of fun doing theoretical stuff, but working in a lab and actually working with bacteria, I was looking around for positions, and there's a sustainability position. So complexity science, the real world project at the University of Surrey. So one of these 4 big projects, actually trying to kind of take these ideas of complexity science and evolving ecosystems, as we're looking at the Erie project in Surrey, saying, okay, can we actually do anything with this? Is it just a kind of nice kind of toy analogy, or can we actually use these tools to do something real in a social context, and particularly here in terms of looking at sustainability in industrial ecosystems? So that definitely appealed to me.
Okay.
Yeah, so that's sort of potted history, I suppose.
Yeah, and you mentioned Southampton.
Yes.
So you're working with, what was it, Richard Watson and...
Yeah, Richard Watson and some of the students there, but also I was working in biology with Jeremy Webb and Lex Crayveld, and so we had a kind of collaborative project. So I spent most of my time actually in the lab in biology.
Doing proper science?
Doing proper science.
Wet science?
Yes, yes.
Okay.
And I thought bacteria were complicated. Moving from models to bacteria themselves seemed like, this was far more complex than I'd encountered. And then I moved into social systems.
Yeah,
and then again, order of magnitude more.
Indeed. Okay, so we've got this university strategic research group called Complexity in a Real World Context. And it seems as if you really are doing complexity in a real world context, because you work with industrialists. So what's it been like to go from, quite rarefied academic community to people who think about, pounds and infrastructure and real world issues?
It makes an enormous difference, because you really have to prove yourself as an academic going in there. So one of our major challenges was going up to Humberside, which is where we're doing our project, where our case study is, and trying to convince people that we had anything at all that could interest them, because in order to do any work we needed data, we needed information to kind of put models together. And really they've seen so many academics, everyone's really excited to hear about what's happening in industry, but for them their time really is money. It sounds like a cliche, but why should they waste their time on you? So it's very important for us to actually think about how to sell complexity science.
Okay.
How we could match the sorts of things we could deliver with things that were interesting to them. And a lot of that was by actually coming up with practical examples that we could think of where a model, if you'd have employed that model as, say, a power station who was investing in co-firing rather than just burning coal.
What's co-firing?
Co-firing is when you burn biomass and coal together.
Okay.
So we had an interesting example which we used to quite good effect, sort of happened upon this model in which someone had done work for the South African energy industry. And they'd looked at what would happen in an evolving biomass market and what would happen if power stations and others just sort of acted by the sort of sensible rules that they might under changing economic conditions, but a power station started to co-fire with bagasse, which is sort of leftover residue from sugarcane production. And what we could actually show that happened in that model was actually, as the economics developed, it became more profitable for the sugar mills themselves to generate electricity burning the bagasse themselves, because it was so bulky that it wasn't economic to transport anymore. And then they would distribute it via microgrids, completely sort of missing out the power station, and the power station's investment in a few years' time became redundant. So you can see there, immediately you've got an example that people wouldn't necessarily have thought of that's coming from the dynamics of the model, but it has real economic impact, and if you're an industrial player in that system, if you were the power station, that's the kind of strategic thing that you might like to know. So it was kind of coming up with examples like that, but also, you know, there's a constant tension really, because you know they are having to work to kind of short time scales. It does matter to them how much things cost this year. And
so I mean, to what extent do they value the blue sky research, the conceptual models, the very broad class of results that maybe don't apply directly to the real world? I mean, is that something that they think academics just have to do, and so they incorporate it? Are they slightly irritated by that?
Well, it's interesting. You know, when we've done participatory modelling exercises with them, and they're always coming up with sort of ideas like, oh, you know, tipping points or things like that. They're quite kind of au fait with all of those ideas in some general sense, and so I'd say they are interested. In some ways, it's been quite good to go out and do practical modelling exercises with people, because then the connections become more obvious. I mean, I think it still always has to be grounded. You could never go and make or at least you wouldn't start with making a very sort of abstract presentation to people. But it's all about kind of finding pathways into things.
They wouldn't buy into that, I guess. Something too conceptual. They just.
Well, not if you sort of started out with that. Absolutely not. And I think that also that is that issue in terms of. They want to see the requisite complexity in the model, but what seems to them to be the requisite complexity might be completely different from what you believe is the requisite complexity. Because there's always a counterexample to everything that you might put into your model. These systems are phenomenally sort of contingent on, you know, just, you know, Fred knowing George down the road, or this regulation change here, or what the Environment Agency happened to do, you know, the other year. You know, for people to be convinced by your models, they have to sort of, you know, they have to have enough complexity and people to recognise themselves in the models.
You often find that the assumption is that if it's got more bits in the model, it's more real. Therefore, its output must be somehow more trustworthy.
You do,
right?
so you've got to work with that. And I don't mean you've got to con people, but I think this is why participatory modelling is a good approach actually, because you can start to demonstrate these things to people, and you know that they start to get a real understanding of it themselves. It's not just you saying that this is the case. You know, these are clever people. You know, all of these industrialists. Well, we work a lot with environmental managers and technical directors and people like that. You know, they're clever people and they can grasp these things, but it's just giving them a route into it in some sense.
Okay. Yeah. So when you mention you've got a complex model, I mean, can you give me an idea of just how complex it is? I mean, how many kind of elements you've got in there? How long does the model take to run? Could I imagine seeing it all defined on a single piece of paper, or is it one of these tremendously complicated models with loads of interdependencies?
Well, what you're going to be seeing is the model under construction at the moment. So even simple versions of that model take hours to run currently, and they're very, very simple conceptual versions. So we're approaching this not with one gigantic model actually, but with a sort of zoo of different types of model, hopefully to address different aspects of the questions. But the metabolic network that I'm going to be showing you mainly today, that has, I think, 45 different types of functionally different agents, which is quite a simplification. And, well, you know, there are sort of... but there are not numerous instances of all those different types of agents, and we haven't yet gone through a process of... they're not necessarily all going to appear in the final model, I mean, part of the process that we're doing constantly is trying to redraw our boundaries around questions, really, sort of what actually matters in the system.
Okay.
But if you draw out the metabolism, even on a relatively sort of low resolution level, you have tens of different actors and hundreds and thousands of connections between them.
And in terms of the stakeholder involvement in the project, how much do they want some kind of predictive tool that spits out an answer and tells them to do X or tells them to do Y? Or how much do they want to use the model as, you know, like a tool for exploring different scenarios?
I think it varies with the different kinds of stakeholders. I think the industrialists are actually quite open to the sort of exploratory tool, and certainly in the workshops we've run with them, they've found that very useful, sort of starting to think about how their system might work. I mean, I think, you know, ultimately they'd like something that told them what to do, but they do enjoy kind of getting their hands dirty, and in some sense it's maybe because they're engineers, a lot of those people, you know, politicians, local politicians, but the national policymakers, that remains to be seen. And we've got 4 more years to run of the project, and we've just brought on people now who are we're starting to work more with central government. We have had a lot of interest from them, but as yet we haven't been taking results back to them.
Okay.
And I think that's going to be a whole different question to address, because famously the minister wants a single line answer, and you know, how do you deal with
the summary of the executive summary of the
So, you know, that's we've got a PhD student just started exploring that very question. So.
Okay. So the project's got another 4 years, is it?
Yes, that's right.
Okay. So if everything works, and of course it will, in 4 years' time, when you all go your separate ways, what do you hope to have achieved? I mean, that could be personally, what do you hope to achieve, but what do you think the project might have done?
Well, I'd be happy, sort of modestly, I suppose, if people in the Humber region, if some of the key strategic actors in the Humber region had a knowledge of complexity, and then their system as a complex system, and sort of an ownership of that system as a complex system. That would really be what I would like to see. I mean, I would like to have done something useful there. I would have liked to have helped people make decisions that made the region more sustainable, but the reality is what we'll probably just be able to show is that there are these big economic forces driving things one way or another, and these are interventions you could make, but whether we can persuade anyone to make those interventions, I don't know.
Okay. But
I mean, I'd be happy with people in the real world knowing more about complexity and themselves as being embedded in a complex system.
Okay.
But I think we can do a lot more than that. I mean, I do think that we can actually develop or go, you know, make steps on this very important pathway towards complexity science being something useful in the real world. And there is a real gap there, and you know, the more we can do to build up towards that objective, you know, if we've taken some concrete steps towards that goal, then I'd be happy.
Okay, well, thank you very much. We all look forward to your talk immensely.
You're welcome.
And yeah, please come back to Southampton anytime you want.